Venkata Rao, Professor of Mechanical Engineering, IARE, Hyderabad. Now I will discuss about the topic single source shortest path problems. So in this, the topics to be covered are introduction, Dijistra's algorithm, examples, Bellman-Ford algorithm, examples. Single source shortest path problems. Single source shortest problem is used to find out shortest path from starting vertex to all other vertices in weighted graph. Let vertex 1 is the starting vertex and we should find out path from vertex 1 to all other vertices, either direct path or through the other vertices. Shortest path problems are solved by using Dijkstra algorithm or Bellman-Ford algorithm. In Dijkstra algorithm, directed or non-directed weighted graph can be used for finding out the shortest path, where all the edges are non-negative. All the edges are non-negative. Whereas in Bellman-Ford algorithm, it is also used for direct or non-directed graphs, but it can be used for positive as well as the negative edges. So this Dijkstra algorithm is used for directed or non-directed graph where all the edges are non-negative. In this, relaxation is used to find out the shortest path from starting vertex to all other vertices. Let U and V are pair of vertices, then relaxation means if distance of U plus cost of an edge UV less than or less than the distance of V, then distance of V is equal to cost of an edge UV plus distance of U. So the distance of V is equal to distance of U plus cost of the edge UV. Example, consider the problem. Now 1 to 2, the weight is 6, 1 to 3, the weight is 3, then 2 to 4, the weight is 2, and 3 to 4, the weight is 4, and 2 to 5, the weight is 5, and 4 to 5, the weight is 2. In this, the starting vertex is 1. Now we can see the adjacent vertices. So the adjacent vertices are 1, 3 and 1, 2. So directly we can change the distances of 2 is 6 and 3 is equal to 3. But the remaining vertices 4 and 5 are not connected to the source vertex. So those may be marked as infinitives. So now consider the example. Solve the following problem using Dijkstra's algorithm. Now here 6 vertices are there. So 1 to 2 is connected, the weight is 50, 1 to 3 is connected, the weight is 45, and 1 to 4 it is connected, the weight is 10, and 4 to 5 the weight is 15, and 6 to 5 weight is 20, and 5 to 2 the weight is 20, and 2 to 4 the weight is 15. So these are the weights are given. Now in this we have to start with the vertex 1, that is the source vertex or starting vertex. Let A1 is the starting vertex. Then now you see, let vertex 1 is the starting vertex. Now we have to mark the distances corresponding to the vertices 1 to 2. That is 1 to 2 is how much distance is given as 50. Then 1 to 3, 1 to 3 is 45. Then 1 to 4 is 10. So 1 to 4 is 10. Then 5 is not connected with 1, so that it can be taken as infinitive. And 6 is also not connected, so we can take it as infinitive. So in this we have to select the minimum one. So the minimum is 10. The minimum is 10, so that we can take the selected vertex is 4. The selected vertex is 4. So after selecting the vertex 4, now we have to find out the distances again. So this distance is 50 only. So this distance is 1 to 2 is 50 only. So and 1 to 3 is 45 only. Then this is 10 only. So after finding 4, the next adjacent vertex is 5. So 4 to 5, the distance is 15. But the actually 1 to 4 is 10. 10 plus 15 is 25. But 6 is not connected, so that it is considered as the infinitive. So in this we have to select the minimum. So already this 4th is selected. Already 4 is selected. Now we have to select the next lowest is 25. So the vertex is 5. The vertex selected is now 5. So after selecting 5, again we have to modify the distances. Next. So here when 5 is the 5 is we know the distance of 5, then we can find out the 2. So 1 to 4, 4 to 5, 5 to 2. So 1 to 4 is 10, 4 to 5 is 15, that is 25 plus 20, this is 45. So 3 is only 45, no change. Then the 10 is 4th vertex is already selected and 5th is already selected. So 6 no change. So in this we have to consider this one is already selected, this one is already selected. So now we can select the vertex 2. This is 2. Now after selecting the vertex 2, again we can find out the distances. This is 45 already selected. This is also 45 only. This is 10 only. This is 25 only. This is infinity. So this is already selected. Then this is already selected. This is already selected. So that this is now leftover is 3. This can also be selected now. So that the selected vertex is 3. Now, so again we can consider the remaining, only the 6th vertex is there. 6th vertex is there. 45, 45, 10, 25, infinity only. Like that we can find out the distances. Now you see in the first vertex we selected the first vertex is 4, the distance is 50 and the distance corresponding to 3 is 45 and corresponding to 4 is 10, 5 is infinitive and 6 is infinitive. So in this the 10 is the minimum. So we selected the vertex 4. After selecting the vertex 4, again we found the distances, that is 50, 45, 10 and 25. So in this 25 is minimum, so it is rounded off here and the vertex selected is 5. After selecting the vertex 5, next. So after selecting the vertex 5, again we calculated the distances of 2, 3, 4 and 2, 3, 4 and so 2, 3, 4 and 5 and 6. So 5 is missing here. So this is 6, infinitive, infinitive, infinitive. So in this we calculated like this. So in this the lowest is 45. So now they selected the vertex 2. So next selected the vertex 3 because 45, 45, 10 and 25 is selected. These are the minimums and the distance is 6. Coming to the next. So last, this is infinitive only. So we selected first vertex 2, that is 45. So the distance of vertex 2 is 45. The distance of vertex 3 is 45. Distance of vertex 4 is 10. Vertex of 5, distance of vertex 5 is 25. But 6 is not connected, so it is infinitive only, it is not connected. So this is the solution for the problem. Now consider the another problem. So in this problem, again we have to use the same procedure. So select the one is the starting vertex. So now found the distances. The distance to the distance of vertex 2 from vertex 1 is how much? 2. Then 1 to 3 is connected, so this is 4. So the remaining vertices 4, 5 and 6 are not connected, so that we can take it as infinitives only. Infinity, infinity, infinity. So in this minimum is this 2, so that you can select the vertex 2. Now the vertex 2 is selected. After selecting the vertex 2, again find out the distances. Now the vertex 2 is 2 only. Then vertex 2 to 4. 2 to 4 is now 2 plus 7, that is vertex 3 is 4 only. Vertex 4 is vertex 1 to 3 is 4. 1 to 2 is 2 and 2 to 3 is 1. That means we can change this one is 3 because this is the minimum distance. Next, coming to the 4, 2 to 4 is connected. 2 to 4 means 9. And 5 is not connected. So this is infinity and this is infinity. Now, so in this the minimum is 3, so that we can select the vertex 3. So that can be shown here. So in the first selected vertex is 2. That is 2, 4, infinity, infinity, infinity. In the next one, so in the next case, we calculated the minimum values are, the 2 is already selected. This is 3, this is 9, this is infinity only. Then coming to the next, the lowest is now 9. The 2, 3. After finding this, again we calculated the distances. Here, after 3 to 5, this is 2 only, this is 3 only, this is 9, but 5 is connected here. That what is the distance over here? 3 plus 3, that is 6, and this one is infinity. So in this we have to select the minimum one. This is already selected. This is already selected. So this is selected here. This is selected here. So the next minimum is 6. Now that is corresponding to the vertex 5. Vertex 5 is selected now. After selecting the vertex 5, you can find out the distances again. So now this distance is 3. This distance is 2. This distance is 3. And this is now after finding 4, this become 5. After finding what is the distance 4, so after finding 5, this is 3 to 5, this is 3 plus 3, 6 plus 2 is 8, and then this is 6 only already found, and this is 8. Now the lowest is 4, so now this is selected and the corresponding vertex is 4. Next, coming to the last one, after finding the vertex 4. So after finding vertex 4, this distance may be how much? 5 plus 3 plus 5. 3 plus 5 is, this one is 2 to 4 is 7, and 7 to 1 is 8. Now you can see this. This distance is 10. This distance is 10. So after finding 5, the distance of 6. The distance of 6 is, this is 10. This is 10 only. This is also 10. Then coming to the last one, that is corresponding to the 6. Corresponding to the 6, this is 2 only, this is 3 only, this is 8 only, this is 6 only, this is 9. So now you can select this. So this is selected, this is selected, this is selected, so that finally this is the solution. So what is the distance now? You can see here. So first we selected the second vertex because the distance is 2. Next we selected the vertex 3 because the distance is only 3. Then coming to the, this is first we selected this, next we selected this. After that we selected the 6. Now you can see that one in the next table. So first we selected 2, next we selected 3, and then we selected 6, and then we selected 8, and then we selected 10, 9. So this is the final solution. The distance of vertex 2 is 2, vertex 3 is 3, vertex 4 is 8, vertex 5 is 6, vertex 6 is 9. So like that we calculated the distance in a single source shortest path problem. So from the single source, that is the one is the first source we considered as the starting source or the single source. From that we calculated the distances of the other vertices 2, 3, 4, 5 and 6. So next method is Bellman-Ford algorithm. So this Bellman-Ford algorithm is used to find out the shortest path from the source vertex to all other vertices in a weighted graph. It may be a directed or undirected, and it is slower than Dijkstra method, but it is more versatile, and this is used when the edges are positive or negative. But in Dijkstra algorithm, all the edges must have positive values only. So in the Bellman-Ford method, this Bellman-Ford proceeds by relaxation, in which the corrected distances are replaced by better ones until they reach the optimal value. Let U and V are pair of vertices, then relaxation means if distance of U plus cost of an edge UV is less than or equal to distance of V, then distance of V is equal to distance of U plus cost of the edge UV. Now, in this method, we have to get the solution. We have to relax the edges n-1 times to get optimum solution, where n is the number of vertices. In each relaxation, the answer may change, but final answer will be the optimum. Now, consider the problem. So, in this problem, what we have to do first, just let the one is the starting vertex. If one is the starting vertex, so all other vertices distance should be marked as infinity. All other vertices 2, 3, 4, 5, 6, 7, 8. All other vertices should be marked infinity. So the weights are given as 1 to 2 is 6, 2 to 5 is minus 1, 3 to 2 is minus 2, and 1 to 3 is 5, and 1 to 4 is 5, and 4 to 3 is minus 2, 4 to 6 is minus 1, and 6 to 7 is 7, and 5 to 7 is 3. So, negative values also there for the edges. So, this Bellman-Ford algorithm can be used for the negative edges also. But whereas the Dijkstra method cannot be used. If it is, the answer may be correct or not correct. But in this case, we will get the correct answer even though when the edges are having negative values. Now, let A is the starting vertex. First, we have to list out the edges. What are the edges here? 1 to 2 is the one edge. 1 to 3 is the another edge. 1 to 4 is the another edge. Next, 2 to 5 is one edge. 3 to 2 is the another edge. 3 to 5 is the next edge. 4 to 3 is the one edge. And 4 to 6 is another edge. 5 to 7 is one edge. And 6 to 7 is the another edge. Now, how many vertices are there in this? 7 vertices there. So, how many times we have to relax it? It should be relaxed n-1 times. So, that means all the edges should be relaxed 6 times. Number of vertices are 7. So, number of times relaxation should be done by 6 times. So, first. So, when the starting vertices is 1, the corresponding distance is 0 only. So, in the starting vertex, the distance is 0 only. But all other are infinitives. All other are infinitives. So, in the starting, the distance of vertex 1 is 0, but all other vertices are 2 is infinitive, 3 is infinitive, 4 is infinitive, 5 and 6 and 7 are also infinitives only. The distances are infinitives. Next, in the first one, first relaxation. So, first relaxation, what is the first relaxation? 1 to 2. 1 to 2 means 6. 1 to 2, the distance is 6. Next, 1 to 3. 1, 2, 3, the distance is 5. 1, 2, 3, the distance is 1, 2, 3. So 1 to 2 is 6. 1 to 2. This is 0 only. This is 0. 1 to 2. 1 to 2 is 6. And then 1 to 2. 1 to 3 is 5. 1 to 4 is 5. 1 to 2 is this. 1 to 3 is 5. 1 to 4 is 5. Then, so 1 to 2, 1 to 3, 1 to 4 is over. Next, 2 to 5. 2 to 5 is how much? 6 minus 1 is 5. 2 to 5 is 6 minus 1 is 5. Then 2 to 5 is over. Then 3 to 2. 3 to 2. 3 to 2. So 1 to 3 is 5. 3 to 2 is minus 2. So that it will be changed to 3. So 3 will be 2 will be changed to 3 because the distance is minimum. So we have to consider the minimum distances. So it is updated as 3. Then, so next one is 3. 3 to 2 is that. Then 3 to 5. 3 to 5, how much? This is 3. So 3 to 5. This is 5. This is 1. But this is 5 only. That is the minimum. So that we can take it as 3. So 1 to 3 is 3 only. So 1 to 3 is also 3 only. Because 5 minus 2 is 3. That is the minimum we have to consider. Next, coming to the 2 to 3. 3 to 5 is over. 4 to 3. 4 to 3. 5 minus 2 is 3 only. So 3. 5 minus this is 4 to 3. When it is 4 to 3, it will change it to 3. Then 4 to 6. 4 to 6 is 5 minus 1. That is 4. 4 to 6. 5 minus 1 is 4. Then 5 to 7. 5 to 7 is, so 5 is, this is 5 plus 3 is 8. 8. But 6 to 7 is 4 plus 3 is 7. So in this, we have to find out the distances. In that, we have to select the minimum values only. So that is corresponding to the first relaxation. So in the first relaxation, we got 0, 3, 3, 5, 5, 4, 7. So 1 to 2, the distance, minimum distance to is 3. Corresponding distance to vertex 3 is 3 and 4 is 5 and 5 is 5 only. 5 is 5 only and 6 is 4 and 7 is 7. This is corresponding to the first relaxation. Now do the second relaxation. In the second relaxation, now you can come into the second relaxation. This is 0 only. This is 3 only. So why it is 3? Already we found 1 to 2. 1 to 2 is 3. 1 to 3 is 3. 1 to 4. 1 to 4 is 5 only. This is 3. This is 1 to 4 is 5 only. 5 only. Then 1 to 4. 2 to 5. So 2 to 5 is now 3 minus 1, that is 2. So 3 minus 1, that is 2 only. Next, coming to the 2 to 5 is over. Then 3 to 2. 3 to 2. This is 3. This is minus 2. So that it becomes 3 minus 2 is 1. So now 2 changes to 1. Because this is the minimum, we have to mark the minimum value here. This is 1 only. Then coming to the 6. 6 means 5 minus 1, 4 only. And coming to the 7. 7 is, this is 5. 5 plus 3. Now 5 changes to 2. 2 plus 3 is 5. So the minimum value is 5. So now you can see the values corresponding to the second relaxation. For second relaxation, the values are 2, 0, 1, 3, 5, 2, 4, 5. because the first relaxation the values are reduced to 3, 3, 5, 5, 4, 7, but after second relaxation the values are reduced to 3 is reduced to 1 and this 3 will be as it is and 5 will be as it is, but this 5 is changed to 2 and 4 is as it is and 7 is reduced to 5. Now coming to the third relaxation. Now coming to the third relaxation. So this is 0, that is 1 to 2 is 0 only. 1 to 3 is how much? 1 to 2. 1 to 2 is now 1 only. Why it is 1? Because this is already 3. 3 minus 2 is 1. So now it becomes 1. Next, coming to the 3. 3 is 3 only because 1 to 3 is 5. Now 5 is 5 minus 2 is 3. This is 3 only. Then coming to the 4. 4 is 5 minus 2, that is 3 only. And 4 will be 5 only. Then coming to the 5. So actually 5 is, this is 1 minus 1, it goes to 0. 1 minus 1 is because this becomes 1. When 2 becomes 1, this 2 minus 1 is 0. Then 6 is same as this. And when it becomes 0, this value is 3. Now you can see the values in the third relaxation. In the third relaxation, you can see 0, 1, 3, 5, 0, 4, 3. The same thing we can obtain. 0, 4, 3 only. First relaxation and then previous one. So these are the values we obtained. This is 0, this is 1. Next, corresponding to the fourth relaxation. When fourth relaxation, so this 0 is 1 as it is, that is 1 to 2 is 1 only. Then 1 to 3. 1 to 3 is, this is 1 only. This is 1 to 3 is 3 only, and this is 5 only, and this is 0 only, this is 4 only. That means there is no change. That means we can consider the values 2 to 5. 2 to 5 is the minimum value is 0. So the value of the vertex 5 is 0. Then 3 to 2. 3 to 2. The vertex is 3 and previous value is 3. 3 minus 2 is 1 only. So that we can mark the minimum value for the 2 is 1 and for the 3 is 3. The values are same. So for the fifth relaxation and the sixth relaxation also the values are same. Now you can see here first relaxation, second relaxation, third relaxation is this. So in the third relaxation 0, 1, 3, 5, 0, 4, 3. So in the fourth relaxation the values are same. That means there is no change. 1 to 2 is 0 only. 1 to 2 is 1 to 2 we have to find out. 1 to 2 is 1 only. 1 to 3, 1 to 3 is 3 only. Then 1 to 4. 1 to 4 is 5 only. Then 2 to 5. So 2 to 5 the minimum value is 0 only. Then coming to the 6, that is 4 to 6 is 4, the remaining same. And coming to the 7, now the previous value 5 is changed to 3, so that it becomes 3. So in the fourth relaxation the values are same, and fifth relaxation also the same, and sixth relaxation also same, so that we need not consider values once again. Now what are the distances obtained now? Vertex 1 is 0, the distance of vertex 2 is 1, and vertex 3 is 3, vertex 4 is 5, vertex 5 is 0, vertex 6 is equal to 4, vertex 7 is equal to 3. So these are the distances we got. So the solution is, that means by using the Bellman-Ford algorithm, we can find out the shortest distance from the source vertex to all other vertexes. Here the source vertex is 1, so the remaining values are calculated here. Now consider another example, simple example. Now consider this following problem. So 1 to 2, the weight is 6. 2 to 4, the weight is minus 1, and 3 to 2, the weight is minus 2, and 1 to 3, the weight is 5, and 3 to 5, the weight is 3. So, what is the procedure? First, we have to consider one is the sorting vertex or the source vertex. When it is the distance corresponding to 1 is equal to 0 and remaining vertices are marked as infinitives. So, corresponding to the vertex 2, the distance is infinitive, 4 is infinitive, 5 is infinitive, 3 is infinitive. The same thing we have to mark here. Vertex 1 is equal to 0 and other values are infinitives. Now, so in this, how many vertices are there? 5 vertices are there. When 5 vertices are there, how many times we have to relax it? We have to relax it n minus 1 times. N minus 1 times means 5 minus 1 means 4 times we have to relax it to find out the optimum solution. Now, you see here, so first relaxation. What is the first relaxation? 1 to 2. 1 to 2 is 6 here. Then 1 to 3 is 5. 1 to 2, this one is 0 only. 1 to 2 is 6. And 1 to 3, 1 to 3 is 5. Because these two are directly connected. And this is not connected. So that we can see the values. First relaxation is 1 to 2. Then next relaxation is 1 to 3. Next relaxation is 2 to 4. So 2 to 4 means 2 value is 6 and my edge value is minus 1, so that it becomes 5. So the value of the vertex 4 is 5. Then 2 to 4 is over. Next 3 to 2. 3 to 2. So 3 to 2, then the value of 3 is 5. Value of 3 is 5 here, and 3 to 2 means 5 minus 2 is 3. So 5 minus 3 is vertex 2 changes to 6 to 3 only. Initially it is 6, now it becomes 3. Its value is changed. Now coming to the 5, 3 to 5. So 3 to 5 is how much? 3 is 5 and 3 to 5 is 3. 5 plus 3 is 8. 5 plus 3 is 8. But 4 is 5. 4 plus 3 is 7. So that you can take it as 7. Minimum value we have to 3 to 5 and 4 to 5 is 7. That is corresponding to the first relaxation. Next, coming to the second relaxation. In the second relaxation, what is that? 1 to 2. 1 to 2. First one is initially is 0. 2. When one second vertex is concerned, how much it is? Second vertex is 2. 1 to 2 is how much? 3 only. After changing that one. Next 1 to 3. 1 to 3 is 5 only. Then 1 to 4. That is next vertex is 2 to 4. We have to find out 2 to 4. Here the 2 value is 3. Then 2 to 4 is how much? This 3 minus 1 is 2. 2 to 4. 1 to 3 is over. 1 to 3 is over. Then 2 to 4. 2 to 4. 2 value is previously we changed it to 3. 3 minus 2 is previously we changed it to 5. This is 3 to 2. 3, 5 minus 2 is 3 only. 2 value initially. When again is 3 minus 2, this is 4. So in the second iteration, this is 0. This is 3. Why it is 3? 5 minus 2 is 3 only. Then next one 1 to 3. 1 to 3 is 5 only, no change. Then 2 to 4. 2 to 4. 2 value is 3. This is 3 minus 1, that is 2. So this value is 2 minus 1 is 2. Then coming to the next iteration 3 to 4. 3 to 4. 3 to 4 is how much? 3 to 4 is same as the previous now. But 4 to 5. 4 to 5 is concerned. 4 to 5 is concerned. Now it is changed to 4 to 5. So this value is changed. 4 is changed to 2. 2 plus 3 is 5. Now you can see this one in the second iteration. first iteration is 1 0 3 5 5 8. Then second iteration is 0 3 5 2 5. So 5 2 5 is the second iteration. 0 3 5 5 2 5. This is 8. Then coming to the third iteration. So third iteration is again 1 2 2. This is 0 only. 1 2 2 is same as 3, and 1 2 3 is 5 only. 2 2 4. 2 2 4 is 5 only, and 3 2 2 is 2 only, and 4 2 5 is 5 only. That means there is no change for the third iteration. For fourth iteration also no change. 5 2 5 only. So like that we can see the values. So in the first iteration, so we assumed that 1 is the starting vertex. When it is considered as a starting vertex, the distance of vertex 1 is equal to 0, and all other vertices are infinitives. Next we proceed to the first relaxation. In the first relaxation, the values are changed to, so in the first relaxation, the values are changed to 1 0 3 5 5 8. In the second relaxation, how the values are changed. Now this 0 will be as it is. This 3 also same in the second relaxation. In the third relaxation it is 5, and fourth relaxation it is 2, and fifth relaxation is 5. So next the third relaxation, no changes in the values. 0 3 5 2 5 only. 0 3 5 2 5 only. So like that we calculated the distances. Now you see what is the distance of vertex 1. The distance of vertex 1 is 0. Distance of vertex 2 is 3. The distance of vertex is 3. And then the distance of vertex 3 is 5. The distance of vertex 5 is, no, vertex 3 is 5. And the distance of vertex 2 is 2 only, or the distance of vertex 5 is 5 only. So like that we calculated the distances. That means the Bellman-Ford algorithm is used to find out the shortest distance from the source vertex to all other vertices. So what are the all other vertices? One is the starting vertex. The remaining vertices are 2, 3, 4 and 5. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.